All right, so today we're going to continue on. On Monday, we discussed, we talked about the mean, and we talked about the standard deviation, okay? And we said the standard deviation is equal to the square root of the variance, and what's kind of a useful definition for the variance? So this is a question I've asked you guys. A somewhat useful definition for the variance would the average what? Average squared distance from the mean, okay? And what does the variance tell us, or what does the standard deviation tell us? It's a measure of what? Yeah. Spread or dispersion, okay? So if our numbers are spread out, we expect the variance or standard deviation to be large. Okay, so if there's like a wide variety or wide range of values, we expect that to be quite large. Whereas if the spread is quite small, then the standard deviation would be small. So we looked at the children's ages of two families. There was the one family where the kids were all 4 years apart or something, and then one family where the kids were all 1 year apart. And in those cases, we said the family where the kids are spread out only 1 year apart has small spread. The family where the children are spaced out much more has more spread. Okay. I didn't get to cover the formula for the standard deviation, so I'll put this up here. If you don't like formulas, you don't have to worry about this, but I'll put this here. And this kind of is effectively, the variance is what's inside the square root, okay? And when you take the square root of that, you get the standard deviation. And if you just think of the squared distance from the mean, every x minus x bar is the distance from the mean. And then when you square it, you get the squared distance from the mean, okay? And then the term average just comes in when we say add them up and divide by n minus 1. Okay, so we can see that this formula kind of relates directly to this concept of average squared distance from the mean. Okay, and again, the key here is it is a measure of spread or dispersion. Okay, let's save this. Okay, I just got worried for a second. Okay, so we have that. Measure spread or dispersion, okay? The standard deviation is especially useful when we're trying to decide if an observation is unusual or not, okay? So is a particular observation unusual? Okay. Well, and this all depends, okay? Is a particular observation unusual? Well, we have to think of what is quote-unquote usual or what is typical, and one way to think of what is usual or typical is to use the mean, okay? So we can think of quote usual or typical as the mean, and then so we would say an observation is unusual if it's far away from the mean, okay? Okay? But whatever we're talking about, will probably have different amounts of spread. Okay? So if we're talking about chlorine levels in the pool, there's just a very narrow range of values that are acceptable, okay, in terms of how much chlorine you can put in the pool, all right? If we're talking about, you know, the cost of a car, there's a wide range of values for, you know, if someone says, oh, I just bought a car the other day, you have no idea if they bought a used junky car for like $400 or if they bought, you know, a Ferrari for, you know, $1 million, okay? So there's a huge range in terms of the amount of money someone can spend on a car, okay? If someone says, I bought a candy bar, probably, you know, the range of how much they spent on the candy bar is within just a couple bucks, right? You'd be surprised if they paid less than 50 cents for a candy bar, but you'd be surprised also if they paid more than $3 for a candy bar, okay? Unless you're at Disneyland. So, and even then I think it's like $2.50, right? $7 churros or something, you know. So anyway, you know, what is unusual, okay? So, you know, $7 for a churro, we would say that's unusual, okay? But whereas, you know, $30,000 for a car, $40,000 for a car, $20,000 for a car, you know, these are quite different from each other, but we wouldn't say any of those values are that unusual for the spending on a car here, okay? So it's not just distance from the mean, okay? But it's really distance from the mean kind of expressed in terms of the amount of variation there is, okay? So we're going to come up with this concept of a z-score, which is equal to the distance from the mean expressed in standard deviations. Okay, and so I'm just making up this example here. Let's say in the USA, we'll say the quote-unquote average age of retirement, and this is not entirely factual. I'm just picking some nice numbers here. We'll say average age of retirement is something around, we'll say 61 years. Okay? Quote-unquote average. Some people retire earlier than that, some people retire later than that. Okay? And what we're going to say is we're going to say the standard deviation of retirement ages we'll say is 4 years. Okay? Okay, so what this means is that someone who retires at age 61, his z-score, or her z-score, this person's z-score, the z-score of this person is what? 0. Okay, this person's retirement age is right at the mean, okay? So the distance from the mean is 0, okay? Okay, someone who retires at age 65 has a z-score of what? Exactly 1, okay? This person retired 4 years above the mean, but each standard deviation is 4 years, so we would say the distance from the mean is 1, okay? 1 standard deviation above the mean, okay? Whereas if we go in the opposite direction, someone who retires at age 57 has a z-score z equal to, we will say, -1. Right? Just want to make sure this is okay with everybody, all right? We're all good with our adding and subtracting of 4, so we can see that we're getting 65 and 57, right? Okay, so this is the concept of a z-score, and this is especially useful if we wanted to talk about what is considered usual or unusual. Okay, so we have these rule of thumbs. Okay, or we have kind of this set of rules called the empirical rule. Okay, says that for many data sets, okay, and again we're talking about numeric variables, for many data sets, about 2/3 or 68% of the data is within 1 standard deviation of the mean. Okay, so or another way of saying is within 1 standard deviation of the mean is to say, has a z-score between -1 and +1. Okay. So about 2/3, okay, and we would say, about 95% of data is within 2 standard deviations of the mean. Okay, or, z between -2 and +2. Okay, and then almost all, but not all, okay, almost all, so 99.7% of data is within 3 standard deviations of the mean. Okay, and I'm just going to write. Okay. All right, so if we're going to look at this retirement age example, and we say something along the lines that, if the mean retirement age, again, I'm just making these numbers up, so don't go to the Department of Labor and say, is this true? Okay, and we're going to say the mean is 61 and the standard deviation is, what did I say, 4? Okay. So we would say, about 2/3 of people retire between what ages? '57 and 65, right? This is z equal to -1 and z equal to +1. Is that okay? All right, and then if I want to say about 95% of people retire between the ages of what and what? And we would say what? 53 and 69, okay? And, I don't know that much about retirement, but this sounds reasonable to me. Okay, and so this would be, z equal to -2 and z equal to +2. Okay, and we can kind of imagine how this carries out. Okay, so these are good numbers to memorize here. Okay, So the empirical rule is also known as the 68, 95, 99.7 rule, okay? Because that's just 1, 2, and 3 standard deviations away from the mean, okay? And it's true for many data sets, not true for all data sets. Especially, it comes from the normal distribution, which we'll talk about next week and whatever. But I saw a hand up there. There was a question. A question? No question anymore? Okay. Well, any other questions? We're good? Okay. All right, and so with something like this, we can talk about, is an observation unusual? So, going back to that question, is an observation unusual? Kind of our rule of thumb is that if its z-score is greater than 2 or less than negative 2, so, if the z-score is, over positive 2 or less than negative 2, we can consider it unusual. Or we'll say we might say it is unusual. Because about what percentage of the data has z-scores more than 2 or less than negative 2? About 5%, right? So we're saying if you're if you're in the 5%, we might say this is unusual, okay? I don't know, okay? So, so we expect, only about 5% of the data to be more than 2 standard deviations away from the mean. Okay. Another thing we can do is we can compare apples to oranges this way. So even if 2 things are on different, we're talking about 2 different things. Okay. What's more unusual? I don't know. Someone hitting 100 home runs in a season, or someone hitting 400 three-pointers in a season. Okay, so we're talking. So for those of you who don't know, home runs is a thing that happens in baseball, and I think the current record for single-season home runs is Barry Bonds, 72 something. I don't know. What? Anybody know? Somebody should know this. Okay, somebody doesn't know. And then, okay, so anyway, it would be really crazy if somebody hits 100 home runs in a single season in baseball. Okay, that would be a ridiculous statistic. But equally ridiculous would be someone making 400 three-pointers in a season. That's basketball. Okay, if he's far away from the basket and you make the basket, you get 3 points. Okay. It would be equally ridiculous if someone hit 400 three-pointers, but it might actually happen this year. Okay, Steph Curry, all right, okay, playing for the Golden State Warriors team in Oakland, he's at 382 right now. He's 18 away. He's got 4 games to do it. Do you think he's gonna do it? He might, right? Like I'm like, every time I check the stats at night, I'm like, come on, you just need 5 a game. You can do it. Anyway, I'm really excited. He's a great guy. All right, okay. So anyway, we can say, what's more unusual, and both of them would probably, 100 home runs or 400 three-pointers, they probably would both rate at having z-scores of something really crazy, like a z-score of +4 or a z-score of something like that, okay? So we can, with z-scores, we can compare things or people, things from different groups. Okay, and we can say what is more unusual? And to answer that question, you just pick out the thing that has a larger z-score. Okay, the one with the z-score farther from 0. Okay, so if you have a z-score of -6 versus a z-score of +5, you'd say the z-score of -6 is more unusual. Okay, a z-score of -6 would be absolutely ridiculous anyway. That's like 1 in a million. Okay, so like, what's more unusual? A Chihuahua? How do you? I don't know. Chihuahua, whatever. Okay. The little dog, Chihuahua, that weighs 15 pounds, or the, I don't know, Great Dane that weighs, I don't know, 120 pounds. Okay. Well, this would involve me finding up, I would need to find out the exact, what's the mean and what's the standard deviation, and then I would need to know the mean and standard deviation. But then once I have those, I can get the z-score, and over here I can get the z-score also, and I would compare z-scores, okay? So I don't know. What's the average weight of a Chihuahua? Anybody know? Well, let's ask Google then, huh? Average weight of Chihuahua. Three. Okay, so they're tiny. All right, so okay, so yeah, so a 15-pound Chihuahua, we would say something's quite severely wrong. Okay, average weight of Great Dane. Okay, and then so, well, I guess, so if we're looking at male Great Danes, apparently we have a tiny, like a little one, so so clearly just from the range that we're looking at, seeing this, according to Google, the 15-pound Chihuahua would be highly, highly unusual, whereas the 120-pound Great Dane is quite mundane, okay, quite ordinary. Okay, and then that would be reflected in the z-scores. Okay? All right. Is that okay? All right. Let's move on then. So we left off, we talked about mean and standard deviation, and then we said for skewed data, and really for any set of data, we have the median, okay, and then we have the IQR. But before I can talk about the IQR, which is the interquartile range, so the median would be kind of a measure of center. The IQR, excuse me, is a measure of spread. Before we can talk about the IQR, well, we would say the IQR is defined as Q3 minus Q1. We're going to have to define what Q3 and Q1 are. So Q3, well, it makes sense to start with Q1. Q1 is the first quartile, and Q3 would be the third quartile. Okay? I'm also going to throw the median down here because I think it makes sense to talk about this stuff. So the median, we can think of the median as the 50th percentile. Okay? And what the 50th percentile means is that 50% of the data have values smaller than the median. Okay, and then the first quartile would be the 25th percentile. And this means 25% of the data have values smaller than the median. Okay. I can't believe the Warriors lost last night. To the Bucks of all teams, right? Okay. Sorry, anybody from Minnesota. I don't believe in your team right now. 75% of the data have values smaller than. What, did I write median here? See, I'm not even thinking. Okay. Have values smaller than the Q1. Value smaller than the first quartile. Sorry, I apologize. 75% of the data have values smaller than Q3. Okay? Are these definitions okay? So the median, half of your data is going to be smaller. Q1, a fourth of your data is smaller. Q3, 3/4 of your data is smaller. Yes, question.
So what, I don't know, you put like Q1 twice, but I feel like they have different meanings at the beginning and the end of your statement. So like at the end, when you say 25 of the data has values smaller than the Q1,
Yeah.
is that the cutoff at the top of Q1? Does that make sense? Like at the top of the range of Q1?
So Q1 is just a single number, okay? So Q1 is a number, and what we're saying is that, I don't know, if we had all of you students here, and we said, I don't know, and we asked, how much money is in your bank account right now, okay? If you told me, right? So, you know, some people have $0 in their bank account. Some people have, you know, maybe couple thousand dollars in their bank account, okay, depending on who you are. Okay, we would have to make up some number, okay? And I'm completely making this up. I have no idea what any of your personal wealth looks like, okay? So if we said, you know, the median is at $800, we're saying half of you have less than $800 in your bank account. Half of you have more than $800 in your bank account, okay? And then we can say the 25th percentile is $300, okay? And what we're saying is that 25% of you, so if there's 160, and I don't think all of you are here today, but if the class was full with 160 students, what we're saying is basically 40 students have less than $300 in their bank account, and everyone else has more than $300. And then, you know, the 75th percentile, I don't know, that $1,500, I have no idea, okay? And we're saying 75% of the class has less than that, whereas 25% have more, okay? So anyway, that's what we're saying. So does that make sense?
Yeah.
Okay. All right, and so, you know, yeah, if we're talking about, you know, bank account values for our class, okay, again, completely making up these numbers, we'll say the median, $800. I'm not going to make anybody raise your hand. Who has more than $800? And then, you know, Q1, who knows? 300, Q3, I'm making all of this up, 1,500, okay? And then, you know, there might be, you know, the 1%er who has, you know, $20,000 in their bank account, all right? Who knows? Or more. Okay, and so what we're saying is that, you know, 25% of students have less than $300 in their bank account, okay? So in this case, our IQR would be 1,500 minus 300. Our IQR is $1,200. This is the range of the middle 50%. Is this good with everybody? Okay, so let's talk about, you know, if I gave you a data set, can you figure out the quartiles and whatnot? Okay, so we'll say finding the median and the quartiles, okay? All right, so let's pretend we have test scores, okay? Well, I'm going to just write this. Step 1, and this is the most important step, is always start by arranging your data in order from least to greatest. Okay, this is a very important step, okay? If you don't do this, arranging from least to greatest, it's gonna get all messed up, okay? So, a lot of times, you know, in the homework problems, the data is already given to you, arranged in least to greatest, but maybe on a quiz or a test, I won't give them to you arranged in order from least to greatest, so don't forget to do this step, okay? All right, so then, and then you, step 2, find the median and quartiles. All right, let's say we have 12 test scores, okay? Okay, so I'm gonna arrange these from least to greatest. So we've got, let's say we got 60 and 70 and 72 and 77 and 78 and 78 and 81, 84, 86, 90, 94, 96. Okay, 12 test scores. All right, so the median, we say half are smaller, right? So if I've got 12 test scores, how many are going to be smaller than the median? 6, right? Okay, so the median is the spot half are smaller. So we say, okay, 12 divided by 2, this is 6, so 6 values are smaller. Okay, that's easy, all right, because we've got these arranged from least to greatest, so we go, okay, 1, 2, 3, 4, 5, 6. I'm going to draw a line right there, okay? And then so I've got 6 numbers that are smaller, I've got 6 numbers that are bigger, okay? So my median is between 78 and 81, okay? So what I'm going to do is I'm going to say my median is going to be equal to the mean of 78 and 81. So I do what? 78 plus 81 divided by 2. Okay, 159 divided by 2 is 79.5. So my median is 79.5. Simple enough, right? Okay, and then so to get our quartiles, Q1 is the first quartile. Okay? Well, if you want to split a piece of bread into quarters, you'd probably cut it in half, and then you'd take each of those halves and then cut those in half, right? That's exactly what we're going to do. Okay? We got 12 here. We took the median, excuse me, and that split it in half. So I'm going to just take these 6 numbers here and split these in half. Okay? So we're going to like find the quote median of the lower half. All right? Make sense to everybody? Okay. All right, and so I've got, where's that going to be? Right here, right? Between 72 and 77. So this is going to be Q1, okay? So Q1 is going to be between 72 and 77. All right, so I do 72 plus 77. I divide that by 2. I get 74.5. So Q1 is equal to 74.5. Okay. All right, so what's Q3? Just yell out a number. 88, right? Okay, anybody having trouble getting 88? Q3 is 88. It's going to be right here. Okay, or I should write Q3. So Q3 is equal to 86 plus 90 divided by 2, 88, okay? And that would be the median of the upper half. Okay, so finding the median, you just find the spot where half are smaller, and then finding Q1 and Q3, you just take, you pretend like the median has split your list into 2 lists, and you find the halfway point of each of those smaller lists. That's all you got to do, okay? You know, if you had an odd number of values, then things change ever so slightly, okay? So we'll take a look at that, okay? So let me see if I can copy these here. Okay, so now I'm going to pretend I have 15 test scores, but I'm going to erase these blue lines here. So I'm going to just add 3 more test scores. Okay, so we'll stick on 57 and 97 and 100. Okay, so now I have 15 scores. Okay, so what do we do? All right, so the median, we want the spot where half are smaller and half are bigger, okay? So if we do 15 over 2, we get 7.5, okay? So what we're going to do here is we're going to say 7 are smaller than the median, 7 are larger, and we will say 1 value equal to the median. Okay, and so this is how we handle having an odd number of values, okay? So I count, I go 1, 2, 3, 4, 5, 6, 7. 7 are going to be smaller, 1 is going to be equal, and 7 are going to be larger. 1, 2, 3, 4, 5, 6, 7. Is that okay? So 7 are smaller, 7 are larger, 1 is equal to the median. Okay, and then so here, my median is equal to 81, all right? Now, depending on the textbook you read, they might have different rules about what comes next. We're going to follow what our textbook says, which says, okay, ignore this 81, and then just take these 7 numbers, and then take these 7 numbers to get Q1 and Q3, okay? So now for Q1, okay, I have 7 values, 7 numbers smaller than 81. Okay, and then we want to find the quote median of those. Okay, so 7 over 2 is 3.5. So we're going to have 3 smaller, 3 larger, and 1 equal to Q1. Okay, so what is Q1? 72. Okay, so we just kind of split it right here. So this is the median. This is going to be Q1. So I've got Q1 equal to 72. All right, and then we just follow the same rule. What's Q3? 94, right? Okay, so following the same idea. Okay. Any questions? We're good? Okay. All right, so what's our IQR in this case? 94 minus 72. What is that? 22? Can I do subtraction? Okay, so that's finding the median and the IQR and all of that stuff. Okay. Let's see. Do I need to say anything else here? Okay. Okay. All right. So we've already talked about the mean versus the median, right? So when do we? Okay. Mean versus median. Maybe I should move this in the middle. What is kind of the conceptual definition of the mean? The balance point of our data. Okay, what would the conceptual definition of the median be? We will say this is the halfway point. Okay. The mean is or is not affected by extreme values? Is, okay? Is affected by extreme values. Okay? The median is not affected by extreme values. Okay. And then so, I guess those are the two key points I want you guys to know about the mean and the median. So, you know, this might be quote unquote preferred for symmetric data. Oh, I know what I want to say. And then this quote unquote might be preferred for skewed data. But again, these can be calculated for any set of data that we have. So if you have skewed data, what happens, okay, and this is just a very cartoonish illustration here that will be over exaggerated. You'd have the median and you'd have the mean. Did I already draw this picture for you guys? I don't know. I teach. Okay, so the median is over here, and then the mean is over here. And what we say is that the mean gets, quote, pulled out in the direction of the skew. Okay. Okay, and then let's talk about standard deviation versus IQR. Okay, standard deviation we can think of as the variance, so quote, you know, square root of the average square distance from the mean. That equals the variance, and the standard deviation is the square root of that. Standard deviation is affected by extreme values. Okay, the IQR, this is the range of the middle 50%. of the data. Okay, and this is not affected by extreme values. And you can look at how we calculate the standard deviation, how we calculate the IQR, and I think it'll be clear that the IQR is not affected by extreme values because it really doesn't care what happens at the fringe, whereas the standard deviation takes into account all values, and so it is affected by extreme values. What is preferred in what situation? Well, it just depends on whether or not you want your summary statistics to kind of reflect the presence of extreme values. Okay? If you want that, then you'd use the ones that are affected by extreme values. And if you don't care about extreme values, then choose the other one. Okay, we'll end there. We'll see you guys on Friday.